Assalamualaikum and good morning to Dr. Umu. We from group number 5 will present a report on mathematical modeling on scheduled waste generation in Malaysia. This is our group members, group number 5. So I will state the problem statement. The problem that we have is scheduled waste generation is the most important thing that we should focus on since our country, Malaysia, is getting higher about pollution cases due to the harm waste that produced from industry, manufacture, hospital and other sector. Scheduled waste refer to any waste that has hazardous properties and may have an adverse effect on public health and the environment. The main source of producing hazardous waste are industrial and manufacturing process. Other generator can be household or commercial group. There is a wide and various range of industry to produce hazardous waste, for instance chemical manufacturing, oil refining, waste acid and electroplating companies. This raises a question in our minds. What is the mathematical model of the scheduled waste generation in Malaysia in the upcoming 5 years? We will make a mathematical model to predict what will happen to the next 5 years scheduled waste generation based on the collection of waste. Next, the objectives are to establish a medium-term prediction model for scheduled waste generation based on the collection of waste generation data, and to analyze the current accuracy and practicality of the model.
Next is literature review. As we know, Malaysia is a rapidly developing country and most competitive economy. As a country involved in a lot of industrial activities such as manufacturing, construction, agriculture, mining and hazardous waste are unavoidable. Hazardous waste is defined as scheduled waste in Malaysia. Scheduled waste are any unwanted matters, whether in solid, semi-solid, liquid or gases, which if released to environment. It can be a potential hazard to human and the environment. One of the potential beneficiaries of hazardous waste is the cement industry. A huge cement plant produces several thousand tons of clinker per day. Therefore, the demand for energy is high and must be met continuously. So we did some research. According to Mahidin, the quantity of scheduled waste generated by industries in Malaysia recorded 7185.2 thousand metric tons in 2020 compared to 4013.2 thousand metric tons reported in 2019. This was contributed by power plant and water treatment plant industries, which is categorized as essential service. So for the data is collected at different points in time with the aim of forecasting the scheduled waste generation in the upcoming 5 years in Malaysia. Table 1 presents the amount of scheduled waste in Malaysia in year 2010, 2014, 2015, 2017 and 2019. If we look at the table, it contains year and amount of scheduled waste in thousand tons. So for first year, which is 2010, amount of scheduled waste in 2000 ton is 1880.9. For 2014, 1665.3. 2015, 2918.5. And 2017, 2020.0. And last for 2019 is 4013.2.
For the model development, we use Microsoft Excel and Maple software to create several mathematical models. We can choose the best regression model by analyzing R square, which is known as relation coefficient. By using Microsoft Excel, we analyze the data to produce an effective model to estimate and forecast schedule waste. The least square method is used to find the regression line. Trend line is the option to show general pattern of data over time. It is called the best fit line, which visualizes the general direction of the values. Uh, there are various types of mathematical models can be obtained from Excel, such as exponential, linear, logarithm, power, polynomial difference equation, and others. As we can see the graph in appendix 1, after we plot the data by using the Microsoft Excel software. Figure 1 is the time series data plot, and the figure 2 time series data plot with linear trend line. We can see the blue line is the trend line. Figure 3 is the time series plot with exponential trend line. Figure 4 is the graph for time series plot with the polynomial trend line of degree 3. This is the best result that we got. And then for the figure 5, time series plot with polynomial trend line of degree 4. And same as the figure 6, time series plot with the polynomial trend line of degree 5. The result that we got for degree 4 and 5, in the solution and analysis, the polynomial regression for degree 4 and 5, the R square error as 1, then we cannot choose it because them show the negative values for the amount of schedule waste from year 2011 to 2013. We do the comparison. The polynomial regression of degree 3 gives the best approximation of the relation between the dependent variable and independent variable, since the R square error is the best closer to 1. And the closer to 1 is the better the line fits the data. After we got the best result in the graph, we consider it is our mathematical model with shown in figure 4. Then we use the general cubic polynomial regression model, where the beta 0 is a population regression constant, beta 1, beta 2, beta 3 are population regression coefficient for variables x, x square and x cube respectively. After that, we plot the data. In the figure 7 is the graph that we got by using the formula of the. To validate the model, the Taylor formula is expanded on the polynomial degree of 3 mathematical model. Then, the suitable expansion order n is chosen, and the new model for the prediction of the amount of schedule waste in the upcoming 5 years is established. We do the Taylor series expansion by using the Maple software as shown in the appendix 3. As a result, the most appropriate expansion order n will be order 2, since it was located at the same position with the line of original data.
As we know that the best mathematical model is the polynomial equation of degree 3. Hence, we form a table of polynomial regression of degree 3. It shows the values for each coefficient. By using this table and the polynomial equation, we can calculate the estimated values for our model. We plug the x values, which is the independent variable, year, accordingly to the polynomial equation. We can obtain the forecasted values of scheduled waste in the upcoming 5 years. In conclusion, We use the polynomial of degree 3 regression model to forecast the amount of scheduled waste in Malaysia. In year 2020, the model forecasted 3,181.8 thousand tons of scheduled waste will be produced. The waste generation is predicted to grow to 4,269.8 thousand tons in year 2024. The aim of establishing this mathematical model is to make people aware of the danger of increasing waste generation. We should take some initiatives to do waste management and always follow the 3 R's, which are reuse, reduce, and recycle, to prevent the massive waste generation and avoid the bad effects to people's health and the environment. These are the references for our report. That's all from us. Thank you.